Okay, let's review chapter 4, sections 1 through 4. This is the matrix chapter, so let's review those first 4 sections. I suggested that you start with page 185, problems 1 to 8. So here we go. The first one says, state the dimensions of each matrix, then identify the indicated element. So remember, rows go across and columns go down. So this is a 3 by 2. This is asking what is in the third row, second column. Third row, second column is a 1. Okay, this is a 2 by 3. The second row, second column is -2. This has 3 rows and 3 columns, so it's a 3 by 3. This one says what's in the first row, the third column. First row, third column. Looks like a 5. Okay, moving on. Then we have all of these, we have the 4 matrices here at the top, and they ask us to do some things with them. Remember, we can only add and subtract if the matrices are the same size. So, first we have to decide if we can do it, and then if we can, we will accomplish the task. Give me just a second here to readjust. There we go. Okay, let me pull this down a little. I think they're all in there. Okay, so the first one asks us to add A and C. So A is a 2 by 2. C is also a 2 by 2, so yes, we can add them. A plus C, so we're going to add 3, 1, 5, 7, and -5, 3, 1, 9. Remember, it's element by element, so 3 plus -5 is -2, 1 plus 3 is 4, 5 plus 1 is 6, and 7 plus 9 is 16, and here is our answer. The next one down here says take B and subtract A. Well, they're both 2 by 2, so we're okay. So B is 4, 6, 1, 0. A is 3, 1, 5, 7. We again subtract element by element, so 4 minus 3 is 1. 6 minus 1 is 5. 1 minus 5 is -4, and 0 minus 7 is -7. The next one involves scalar multiplication. It says multiply everything inside of D times 3. So it looks like this. So, doing a little math, 3 times 1.5 is 4.5. 3 times 2 is 6. 3 times 9 is 27. And 3 times -6 is -18. The next one asks us to multiply B times A. Now remember, when multiplying 2 matrices together, we have to write their dimensions down. So that's a 2 by 2 and another 2 by 2. If these match, we're okay. And they do. So we're going to multiply 4, 6, 1, 0 times 3, 1, 5, 7. Okay, remember how multiplying works. We multiply these 2 numbers together plus these 2 numbers together. Then we skip over these 2 numbers together, then these 2 numbers together. We go to the bottom row. 1 times 3 is 3. 0 times 5 is 0. 1 times 1 is 1. 0 times 7 is 0. So our answer is 42, 46, 3, 1. Like so. Now number 8 asks us to do quite a bit. All of our matrices are 2 by 2, so it's perfectly legit to do them all. So we're going to start on the inside, and we're going to do D times B. D is 1.529 -6. B is 4610. So 1.5 times 4 is 6. 2 times 1 is 2. 1.5 times 6 is 9. Sorry, bad math. 2 times 0 is 0. 9 times 4 is 36. Negative 6 times 1 is negative 6. 9 times 6 is 54. 0 times negative 6 is 0. That is, let me fix that, 1.5. 2 times 1 is 2. That's a 2, just in case. All right, so we end up with, we're going to put C over here, so we'll put D right here, or the BD right here. So we get 8, 9, 30, and 54. Now we multiply that times C on the left side. So negative 5, 3, 1, 9. Okay, I may need a calculator here. That's negative 40. 3 times 30 is 90. Negative 45. 3 times 54 is 162. 9 times 1, or 8 times 1 is 8. 9 times 30 is 270. 1 times 9 is 9. 9 times 54 is 450 and 36, so 484. Final answer, I'm going to make sure I did this right, is 50. Yep. 117. Yep. 278 and 495. Oh, that should have been a 6, not a 4. There we go. We got it. Okay, that is 1 through 8 on page 185. Let's keep going. The next thing I asked you to look at was on page 225, and to shortcut this, I'll read the questions and fill in the blanks for you. So let me get to page 225, otherwise we'll never get done. Okay, a blank is a rectangular array of numbers, that's a matrix. Transformation, or translations, dilations, reflections, and rotations are all transformations. Number 3, Cramer's rule uses determinants to solve systems of equations. Number 4, if corresponding elements of a matrix are equal, then the matrices are equal matrices. The additive inverse of a matrix is the zero matrix. A blank consists of coefficient matrix, a variable matrix, and it's a matrix equation. Number 7 is an n by n matrix is called a square matrix. Number 8, the image of a figure is a transformation of the pre-image. Let me go up here. So number 9, the product of a real number and a matrix is called a scalar product. And number 10, a matrix is the inverse of another matrix if their product is the multiplicative identity. And that is correct. Okay, then we're back to what we were doing a few minutes ago. Right back at the same questions again. So, what are the dimensions? This is a 2-row and a 3-column. What is in the first row, third column? It's -7. This is a 3-row, 2-column. What's in the second row, first column? A -5. And last but not least, we have a 3 by 3. What's in the third row, second column? It's 78. Okay, you can always rewind and review. This is my blotter page. Okay, number 14. Looking at this matrix right here. Oops, sorry, I got to scroll down a little bit. There we go. Number 14 says, how many points has Tamika scored? So we would need to add up all of Tamika's points, but remember, these are all worth 2, and these are all worth 3. So we would have 22 plus 2 times 30 plus 3 times 48, and that totals out to be 226. Okay, number 15. How many 3-point shots has Tran made? 3-point shots? 50. What percentage of Joanna's points were from 1-point shots? Okay, well first we have to know how many. She made 200 and, oops, wait a minute, Joanna. Okay, we would have to find her points. So 21 plus 62 plus 48 times 3, 120, 144. I believe that's correct. Add them up. So that's 206, 227. And see, let me read that again. We're from 1 point shots. She made 21. So 21 divided by 227 is about 9%. And that's the question. Cool. All right. Next one. These, it says to add the matrices together to find this one. So let's add. 2 plus negative 1 is 1. Negative 6 and negative 2 is negative 8. 8 plus 4 is 12. So X is that. The next one. Again, we're adding. Or actually, we're subtracting. See the symbol in between. So this one would be, X in this case would be T minus 1 and 3. And really, there's nothing else we can do in this case because we don't know what T is. Okay, next one. Oops, I left off part of the bracket here. Let's fix that. Okay. All right, we're trying to find the X. So as in a normal equation, if we had 7 plus X equals 10, we would subtract the 7 from both sides. So we're going to subtract this matrix and make it go away from over here. That leaves us our X. So X is equal to 4 minus 7 is negative 3. 9 minus negative 1 is 10. Negative 3 minus 0 is negative 3. And 11 minus 8 is 3. There's our values. Okay, and just like the last one, except this time we're going to add. So we're going to add this thing. Negative 7, 13, 5, 3, 31, 0, negative 4. And that will give us our X value. So 9 plus negative 7 is 2. Negative 5 plus 13 is 8. 8 plus 5 is 13. 2 plus 31 is 33. 0 plus 0 is 0. And negative 3 plus negative 4 is negative 7. And we have the value for big ol' X. So far, so good. All right. Again, that's just my blotter page. 21. Okay, now this one is a little different in that they're asking us to find the values of the variables. So we will as we go through. Okay, so remember these are equal matrices, so we just do it element by element. So they're telling us that X minus 5 is equal to negative 7. Well, I know how to solve that. X must be negative 2. Add 5 to both sides. We know that 9 is equal to W plus 1. Well, math tells me that W must be 8. 4 is equal to 8 minus R. So if I add the R to make it positive, R plus 4 is equal to 8. If I subtract it, I get R is equal to 4. And the last one, T plus 2 is equal to 1. T must be negative 1. Not so horrible. Just like that one, let's look at the next one. So we have negative 4 plus t is equal to 2t. If I move that t over there, I have negative 4 is equal to t. I'm done. I know that 2y is equal to 11, so y must be 5.5. I know that r is equal to negative 2r plus 12. So 3r must equal 12, r must be 4. And last but not least, w plus 4 is equal to 9. So w must be 5. Okay, now we're down to matrices that we get to play with again. First one says multiply matrix A times 3. Everything inside matrix A times 3 gives me, I can do that without writing it down, I get 18, 3, 0, 24, negative 12, 9, 21, 33. The next one says take B and subtract 2 times D. Well, B is 1, 3, negative 2, 4. And 2 times D is going to be 10, negative 4, 6, 12. And I'm going to subtract, Oops, I left out the problem there. 1 minus 10 is negative 9. 3 minus negative 4 is 7. Negative 2 minus 6 is negative 8. And 4 minus 12 is negative 8. Final answer. I didn't write down what number 25 was. 25 was multiply A times B. A times B. All right. Well, remember, we always have to check first. A is a 2 by 4, and B is a 2 by 2. These do not match, so it's undefined. Awesome. Okay, however, look at 26. 26 reverses it and says, let's do B times A. Is that okay? Well, that would be 2 by 2 and 2 by 4, and that's okay. So I'm going to move this up a little bit so you have a little space here. Okay, my 2 by 2 is 1, 3, negative 2, 4. My 2 by 4 is 6, 1, 0, 8, negative 4, 3, 7, 11. Okay, so it's row times column. So 1 times 6 and 3 times negative 4. So 6 minus 12 is negative 6. 1 plus 9 is 10. 0 plus 21 is 21. 8 plus 33 is 41. So far, so good. Bottom row. Negative 12 minus 16 is negative 28. Negative 2 plus 12 is 10. 0 plus 28 is 28. Negative 16 plus 44, I believe, is 25. Nope, negative 16 and 44. How about 28? There we go. Got it. 28, not 29. How are we doing? I knew that wasn't right when I looked at it. All right, next one. AC minus BD. Oh, this looks like loads of fun. AC. So I have to multiply these two together? Ooh, okay. AC. You know what? I'm going to grab a sheet of paper here because that looks really long. Hold on one sec. Here we go. All right, so I'm using the same problem. So I'm doing AC times BD. AC minus BD. Okay, so A times C is a 2 by 4. C is a 4 by 2. Yes, I can do it. My answer will be a 2 by 2. B times D is a 2 by 2 and a 2 by 2. These match. My answer is a 2 by 2. And since I'm subtracting, it's okay. So now I just get to do the math. All right. So AC. So A, 6, 1, 0, 8, negative 4, 3, 7, 11. Negative 2, 1, 4, 0, 2, 2, 1, 1. All right, so negative 12 plus 4 plus 0 plus 8. 6 plus 0 plus 0 plus 8. 8 plus 12 plus 14 plus 11. Negative 4 plus 0 plus 14 plus 11. Okay, so do a little quick math here. That makes 12, so that's negative 10. That's 14. That's 20. That's 25, so this is 45. That's 10. That's 21. Minus B times D. Did I do B times D already? I did not. So I got to find B times D. So B is 1, 3, negative 2, 4. And D is 5, negative 2, 3, 6. So that's 5. And 9 is 14. Negative 2 and 18. Yeah, negative 2 and 18 is 16. No, negative 16. That's negative 10 and 12, so that's 2. 4 and 24 is 28. Okay, so I bring that down here. 14, negative 16, 2, 28. And we subtract. Negative 10 minus that is negative 24. 14 minus negative 16 is 30. 45 minus 2 is 43. And 21 minus 28 is negative 7. Whew. Didn't think we were going to make it, but we did. All right. Last page of these. Here we go. Okay, sorry about all the blotches. We'll make it work. Okay, I'm just going to show you the matrix you would add or subtract. I'm not going to mess around with all of these, doing all the math here. Our original matrix, according to the book, is this one. I'm going to switch pens here. And it says to move it right 1 and down 2. So I'm going to take the original matrix, 3, negative 2, 1, 1, 0, 5, and I'm going to add right 1, so that's going to be 1, 1, 1. Down 2 is negative 2, negative 2, negative 2. Doing the math gives me 4, negative 1, 2, negative 1, negative 2, 3. Done. The next one says left 3, up 4. Again, I start with the same thing. 3, negative 2, 1, 1, 0, 5. Left is going to be minus 3, minus 3, minus 3, and up is positive 4, positive 4, positive 4. We do the math. That's 0, negative 5, negative 2, 5, 4, 9. And that is the matrix that I would then graph. Okay, now for reflections and rotations, remember I told you don't have to memorize these, so we're just going to look up what we need to multiply and see what happens. I am on page 1. Let's see, this is reflect over the y-axis, so that's on page 189. Reflect over the y-axis is negative 1, 0, 0, 1. And again, I have the original 3, negative 2, 1, 1, 0, 5. And if you look, the negative 1 on the top is going to change all the signs on the top. So negative 3 to negative 1. Everything on the bottom is going to stay the same. And then we would graph it. Reflecting over the y equals x, 0, 1, 1, 0. Okay, this one flips them. Okay, if you look, if we do 0 first and then 1, it's going to take the bottom row and put it on top, and the top row and goes on the bottom. And there's our answer. Okay, rotating 270 degrees. Again, I look it up. That's on page 190. That's 0, 1, negative 1, 0. 0, 1, negative 1, 0. Okay, notice they switched places, so that means they're going to flip again. Okay. 3, negative 2, 1, 1, 0, 5. Okay, so they're going to switch, and when I switch them, the bottom row is going to change signs. So negative 1, 0, negative 5, and 3, negative 2, 1 is going to be on the bottom. It switches. Dilating by a half is scalar multiplication. So that's going to be 1.5, negative 1, 1/2, 1/2, 0, 2.5. Okay. Dilating by 2 is going to multiply everything by 2. So 3, negative 2, 1, 1, 0, 5 gives me 6, negative 4, 2, 2, 0, 10. And again, we can graph all of these. Rotating 90 degrees. Again, I'm going back. The rotation is 0, negative 1, 1, 0. 0, negative 1, 1, 0. I'm multiplying by 3, negative 2, 1, 1, 0, 5. Okay, they've switched here, so that means the rows are going to switch, And the top row this time is going to be negative. So we do this, -3, 2, 1, nope, -1, and 1, 0, 5. So because these are in this row instead of this, sorry, this diagonal instead of this diagonal, the rows flip. Okay? And that is as far as I'm going to go. I know I gave you more problems to work, but it's just a repeat of the same stuff. And this video is getting really long. So I think we're going to stop. And if you have any other questions, make sure you ask. See you on Tuesday.